In this video, we'll start with the 8th experiment of digital circuits, that is the use of a multiplexer. So the aim of this experiment is to design and implement gate level multiplexers as well as to use MSI multiplexers. So a multiplexer is a device used in digital electronics that is used to select a single output from multiple inputs. So we can have multiplexers of various types, ranging from a 2:1 multiplexer, a 4:1 multiplexer, and so on. So in a 2:1 multiplexer, the 2 stands for the number of inputs, that is we have 2 inputs, and the 1 stands for the output. So we can have 2 inputs, and using a select switch we can select one output. Similarly, in a 4:1 multiplexer, we have 4 inputs and we have 2 select switches, and using these we can select one output from any 4 of these inputs. And in an 8:1 multiplexer, we have 8 inputs and we have 3 select switches, and we have only one output, and we can select this output using the select switches, so it will be any one of these 8 inputs. So for the apparatus we require the baseboard, a couple of ICs, and some jumper wires. So the procedure again is very similar to the previous experiments. You'll have to mount the required IC in any one of the 10-pin sockets, and using the pin diagram you can connect the input pins to logic 1 or logic 0 and the output pins to the LED box or the 7-segment display. You'll have to connect the VCC pin to +5 and the ground pin to the ground pins. Then you can vary the data on the input pins, and you can observe what output you are receiving. Depending on which case you are implementing, that is either the 2:1 or the 4:1, you will have different number of inputs with input pins as well as different number of select pins. For the 2:1 multiplexer, it is advised that you implement it using the logic gates as well as the IC provided. But for the 4:1 and the 8:1 multiplexer, it is preferable to implement it using the provided IC directly. So this is the diagram for a 2:1 multiplexer. We have two inputs here, that is x1 and x2, and S over here is the select switch and Y over here is the output. So we can have x1 and x2 anything from both being 0 to one of them being 0 to both of them being 1, and we can vary, since S is the select switch, we can vary it either from 0 or to 1, and depending on which case we are implementing, as seen here from the truth table, we'll obtain Y as any one of the inputs, that can be x1 or x2. Then we have the 4:1 multiplexer that can be implementing directly using the IC, that is IC 74153. So we'll have 4 inputs over here going from D0 to D3, and we'll have 2 select switches, that is S0 and S1. We also have an enable pin which we'll have to connect, and a Y over here denotes the output. So this over here is the pinout diagram for that IC. As you can see over here, we have the data inputs over here, and the data outputs over here as well, because this IC contains two 4:1 multiplexer within a single package. We have two outputs, one of them is over here and the other one is over here. The ground and the VCC pins are pin 8 and pin 16, and the select switches are also pin 14 and pin 2. And this is the truth table. You can see how the data pins are varied along with the select inputs, which correspondingly give us the output that we want. This over here is the simplified truth table for the 4:1 multiplexer. So if both the select pins are 0, we'll get D0, that is the first input, as the output. If it is 0 and 1, we'll get the second input as the output, and so on. And in this diagram we are showing the 8:1 multiplexer. So for an 8:1 mux, we'll have 8 data input pins ranging from D0 to D7, and we'll have 3 select switches, S0, S1 and S2, and the enable pin that you'll have to connect. And Y over here denotes the output. So on varying the select pins, you can verify what output you are getting, that the output should be any one from D0 to D7 depending on the state of the select pins. So in the next part, we'll demonstrate how you can implement these multiplexers on the mobile lab, and we'll also show you how you can obtain the output using the LED box. And you can note down your observations and verify the truth table, and also note down what you have learned from this experiment.
In this part, we will demonstrate how to connect the IC 74153, that is the 4:1 mux, with the mobile lab.
For this also, you must know which pin is what. Even for this experiment also, you must know the pin diagram of IC 74153, which is 4:1 mux. So here pin number 16 VCC and pin number 8 as ground. After that, pin number 1 is enable, so it must be grounded. After connecting VCC and ground, the pin number 1 is enable bar, so it must be connected to the ground. Here pin number 2 and pin number 14 are the select inputs, which basically select what must be the output of mux. 14. After that, pin number 7 is output. So here we are using the first mux, so the enable pin of first mux is grounded. So this is nothing, this is our connection. Now to check the output, so let us check output when both the pins are 0. The output must be now let us connect the input pins, which is pin number 3, pin number 2, and pin 0. Yeah, so it was about the connection. Now let us try to run on the so here both the inputs, which is S0 and S1, are logic 0, which are 0 0, which it will run the D0 input. So D0 is nothing but a 6th pin. Yeah, so at first it as D0 is grounded, the output is also 0, which means that and when D0 is logic 1, the output pin is logic 1. So we can say that the output of mux is nothing but the D0. Similarly, if we vary the if we make both the inputs S0 and S1 as logic 1, so the binary equivalent of 1 1 is nothing but the 3. So D3 will be considered as output of mux. So D3 is pin number 3. So when D3 is 0, the output of mux is 0. When the D3 is 1, the output of mux is 1. So we can say that the output of mux is nothing but the D3. Similarly, we can vary for another case, which is D1 and D2, by varying the values of S0 and S1. Now let us verify the output of mux. So here S0 and S1 both are grounded, so 0 0. So the binary equivalent of 0 is nothing but 0, so the output will be D0. So that D0 is our 6. So here we can see that when D0 is grounded, the output is 0. When D0 is plus 5 volt, the output is plus 1. So we can say that the output of mux is nothing but D0. If we try to change the case, so here I am making both the values of S0 and S1 as plus 1. So binary equivalent of 1 1 is nothing but the 3. So the output of mux will be D3, which is this. So here we can see that when the D3 is 0, output is 0. When D3 is considered as plus 5 volt or logic 1, the output is logic 1. So the output of mux in this case is nothing but the D3. So similarly, by varying the values of S0 and S1, we can get other outputs which are D1 and D0. That's it.